Good morning and welcome once again to another edition of Python with Professor Thayer from my living room live on this Sunday morning. Let us discuss file input and output. That will be our next topic. So I am going to share my screen with you and let's get our slides up. Okay. So you can certainly feel free to follow along in the video and or to grab the slides off the Moodle site as you like. Let's see, this should grab our slides. Let me put this up for you. All right, let's see. There we go. I think we're in business now. Let's see. Oh, I'm seeing double here. All right, let's see. Okay, here we go. So, lecture 8, file input and output. This is going to be about writing files to your computer and obtaining information that's inside of files. This is an incredibly useful thing that you might want to do pretty much in any computer programming language, because what if you write a program and you want to come back to it, you want to use the data that you've written at a later time. So if you only could use the data by the program itself, then it's not going to be especially useful. So probably many of you do things like write Microsoft Office documents, do spreadsheets, many other things in files that we actually save to the computer. And part of the reason why we would want to save a file to the computer is so we can use that information again at another time. That's called persistence. And so today we're going to talk about how you can work with files using Python. Before we dive into that, let's just take a quick look at our course calendar. So here we are sitting at file input and output. I know you guys are all doing a great job on staying up with all the assignments as best we can and so forth, given the circumstances. Please be just cognizant of getting your homeworks in on time and, of course, working the lab that goes along with today's lecture after you complete this. So you also should be following along chapter 14 files and working on homework 8, which is the one that will be assigned for this. We also have our project preliminary results due this week. So what I'd like you to do is please upload those. Now, should we be concerned if we have not completed the whole project? Of course not. The point of the project preliminary results is to have a look at what you're doing, where you're at. Oh yes, that's my dog who just walked in. We want to see where you're at, see what it is that needs to be done on your project to successfully bring that to completion. So I would strongly encourage you to get some preliminary results in. What I'm looking for is that you've attempted any 2 of the 3 goals you set out for yourself. Let me know what trouble you're having. Talk about it with me. Chat with me online. Send me an email. To get in one of the forums. Let us know. Talk to the TAs. Let us know what it is we can do to help you with your project and help you get over any snags that you might have. Do you have to stick to your original project exactly as planned? No. Oftentimes when we look at your proposals at this point, we might realize that we need to modify your goals, or maybe you discovered that there was some really interesting direction that you wanted to go in. And so it's perfectly fine to be changing up what it is you're going to do for your project. But you do want to just be in communication with me about that. So please upload those preliminary results. I'll be looking for those at the end of this week. Okay, we have one more substantive topic. That's classes, objects, and methods. At the time of recording, I haven't exactly decided what we're going to do for the exam, so I'm going to be in touch with you about that, but it's probably going to be some sort of a take-home exam of some kind. The format may be somewhat different from exam 1 because of the situation, so hold that thought and check the updates that are going to be coming out a little bit later, because I am pre-recording this by a couple of weeks. We normally would have preliminary results, presentations on the projects, and also This is going to need to be modified because obviously we can't do live presentations on your project. So this will probably turn into another check-in with me. Maybe we'll see if there's some way you can, you know, talk about your projects and share this with your peers, because that is something that's really interesting to do. All right, then our final lecture will be applications of programming, which will not be included in the exam. But after you've taken Python, I do want to talk to you about what your other choices are, where you can go from here, and that's what this applications of programming is about. Then we'll have the reading period and get into final exams. So your final project will be due during this exam period. So it'll be Wednesday, May 13th at 5 p.m. when you need to upload your completed Python project. All right, questions, problems, and so forth, be sure to ask me, visit me during some of our online times and so forth. And also you can check in with our assistants. All right, so then let's just get an overview of what's in this lecture. So the first thing we're going to do is have an introduction to files. What is a program and what is a file? We're going to talk about reading and writing files, how you would create, open, read and write to them, close it. We're going to have 4 distinct ways to read a file. Why stop at only 1 when you have 4 ways? And then how to append to files. So it would be no good if you could only write and then clobber it. And we'll talk about idioms, which is a topic we've kind of mentioned throughout the semester, but we're going to talk about it in a little bit more focused way today. The next thing we're going to talk about is navigating the directory tree. So your files and folders on your computer are in fact organized in a logical fashion where the folders start somewhere and they have one folder inside of another. And so we're going to talk about how that setup happens. It's different on every computer because if it were identical, then you would have this, it would be exactly the same computer, but once you start making your own directories and so forth, it changes. And so we're going to talk about that. And the final thing we're going to discuss today is handling exceptions. And this is really just about when you get an error. So far we've just done our best to ignore them or to avoid them altogether. But there are in fact ways that you can anticipate that there could be a problem with something. And then we ask, well, what could we do about it? Could we try something out? Like maybe we want to try to open a file, and then if the file doesn't exist, maybe we could create it. And so this becomes a really useful way of handling things that applies to file input and output, as well as some of the other errors that we have encountered throughout the semester. But your code would never have any errors in it, right? All right, so introduction to files. What is the purpose of having files? So purpose for files could be obtain pre-existing information, data, and or input. So maybe you want to share information remotely with somebody else. We've had a lot of that going on lately. Maybe somebody else has a database, some kind of information that you want to share, something that's pre-recorded. You may also want to retain information generated by a program. So maybe you write something, you write a program, or you start doing your homework, right? You'd like to be able to save that and to use it at a later time. So if we didn't have the ability to save files, as soon as you quit out of it, laptop is turned off, any of these things, the file would be gone. And that would be bad, and you have to do it all over again. So wouldn't it be a good idea if we could write the information to the disk somehow? And that's what creating a file is all about. Persistence. It means that the information is retrievable after the program closes. Basically, it means we're saving a file to the disk. As I'm sure you're aware, there are many different kinds of files that are available, and these are just some little icons to indicate some of the possible things, you know, PDFs, some videos, some pictures, Word document, music, zip files, files with pictures in it. This looks like a movie clip, and a spreadsheet. So many, many kinds of files. We'll be starting off with really simple ones. We'll be talking about reading and writing text files in Python. So let's just preview a program and see if we can step through this and understand what this program is doing. So here we have file read equals open, and this is opening something. So I have a PC. I don't have a Mac, and so this is going to follow the PC format or the Microsoft Windows format for opening a file. And you see that this is on C users Kelly desktop. So there is a file that's sitting on my desktop. And this file, and then after it opens this file, it's going to print opened file. Okay, so probably this line is opening a file, you might guess. Now let's take a look at this. So here we have numbers equals the brackets. So you recognize the brackets as a list, and it's an empty list. So it looks like an initialization is happening here. So if a line in file read, line equals the integer of the line number, lines.append line. Okay, and then we close the file. So it looks like a loop. Something happened here that looped over a file, maybe? And now we have numbers.sort. I wonder what that could do. And now we have file right equals open a file. Okay, so for number in numbers, okay, so that was our list. So it looks like we're cycling over the list. We're going to try to write something and then close. So even if we don't understand all the details of what's happening in this program, we can get the idea that a file was opened and somehow there was some looping over a file and it was closed, and then there was some sorting going on, and then there was a writing event to a new file, and that file got closed. So this gives an overview of some of the kinds of things we're going to see when we are working with files. So as we go through today, we will see how it works, and we'll revisit this later in the lecture once we understand what's happening in more detail. So let's talk about the properties of a file. You could probably identify a lot of these things already yourself. A file has a name, a location, content, and that content may be either text or binary. So what I've done here is I've just gone to my desktop to open a file called numbers.txt and asked to display the system properties on this. And here, going over to the details tab, we see that we have many of these properties that we're discussing, and some additional properties as well, but these are the major ones, right? So we have here, we have the name, the location. So the location is going to be, where is that file stored, right? You have to have the file stored somewhere. And this so happens to be a text file, which I know because of the .txt extension. So that is the typical type of file we'll be working with today, although of course other file formats such as binary that contains data and information, executable information perhaps even, that you could use to do something. So we're not going to be dealing in Python with those kinds of files, although it's possible to do so. That could be something that you wish to explore in your final project. Reading and writing files. So the first thing we want to be able to do is start at the beginning. How do you create a file? So here's what we're going to do. A file is created using the open command. The status of the file determines how the program can interact with it. So there are 3 different formats that you can use, or 3 different statuses: R, W, and A. R is for read, W is for write, and A is for append. So since we're opening a file to create it, we want to write in it. So we need to select the W format or status. So the syntax is going to be the file variable. That's going to be like a name, our file handle, equals the result of opening a file. So what exactly does this mean? It's like you need to specify a variable that you can refer to do the actions on the file that you want. This does not have to be the same as the name of the file itself, but we just need something to hold on to. It's like the result of opening the file. We need something, and that variable is what that something is. So we have a file variable, we'll probably just call it F, or file, equals open. Now here we put in the actual name of the file. Notice that I've got this in quotes because it should be a string. Could you use the variable in here? Yes, as long as that variable resolves to a string. So you could preset it ahead of time, or you can literally put the file name down here, and then you need to put the status. Again, the status needs to be in quotes, and that status type that we wanted to pick for opening a file is W for write, because we want to write to the file. So here's an example. We could do my file equals open I'm going to call this one airplanes.txt, and the status is writing. And when we do this, a file gets created. So here we are overlooking on my desktop, and we see that there is a file called airplanes.txt on my desktop. So now all we've done is just we created the file, but we didn't actually put anything in it. So what use is that? Maybe we'd like to put some content in. So that's what writing is for. So we use the write command in order to write the content to a file. The file must be open already. So you can't write if you didn't open the file already. And the file must have the W status for write. So if you opened it with a different status, you're not going to be able to write to it. The argument of write must be of type string. So sort of like print, when we use the print function, when you print something, the thing that you're going to print needs to be a string. When you write something, the type needs to be string. Also, it's useful to recall that this /n, this is escape, and n stands for new line. Putting this in your string will cause a line break to occur. So let's take a look at what would happen. So you have to use your file variable so that Python knows to which file it should write. If you have multiple files open, you use the variable that prints to the file that you wanted to pick. Notice that we don't use the file name, which might be what you expect it to do. It's the file variable that we defined when we opened the file. So that's how we know which file it is. So it's going to be the file variable dot write, and then you're going to have some text that you want to put in the file. And here's how you would do it if you're going to have a line break in it. So this text includes a line break, and so you see the /n here, which will introduce a return. So /n basically works the same way as if you type something and then you press return to go to the next line. So here's some example text. So a type of single engine plane is, and then we have a colon, new line, and now we're going to have more writing down here, Piper Warrior 2, and so that should come up on the next line. So now that we've written our file, now we need to close it. So the closing a file releases the system resources. So did you ever have the problem that your computer got really slowed down, you didn't have enough memory to do another thing, and what did you do? Maybe you realized you needed to close some of your files. Well, that's part of why we close our files when we're done with them. Releases the system resources. So you want to close your file when you're done with it. It's unlikely that the usage of system resources by writing a Python text file is going to make a big difference on operating of your computer, but it's a good practice to do, and you should really just do it because it really makes sense. You open a file, you should close it. So it's good practice to close all files which you have opened. A file is closed using close. So remember, we talked about functions and how all functions have parentheses. So close is no different. Close is just a built-in Python function that has these parentheses here. So even though it doesn't take anything in the parentheses, it's just a function that has no input parameters. So don't forget the parentheses. If an open file is not explicitly closed, it will automatically be closed when the program ends. Very true, not the best. Good programming skills would show that you actually close. So show that when you open it, all the things you open are also getting closed. So here we have an example of file variable.close. Again, this file variable refers to whatever you called operating with your file when you did the open. So that same thing you pick here, the file variable.close. So my file.close would fit the example we looked at. All right, so here is a Buggy program. Why don't you go ahead and pause this video for a moment and take a moment to look through this and see if you can spot any bugs. All right, welcome back. Did you find any bugs in this program? There are several. All right, so let's just take a moment to go through what it does. So this is reminder, and this is going to take two input parameters, message and out file. And so we see that we take two strings in, and this is returning none type. The message and out file are strings is a requirement. The out file is a valid file name. And what it's going to do is it's going to write a user's message to an out file on the desktop. So it looks like this is going to help us to write a file. So here's our out. Full path is going to be user Kelly desktops. This is going to put something on my desktop. Plus, so this is concatenation using strings and out file. So you see what we've done here is we've prepended the path to where our file is at, more on paths when we get to directory trees, and the out file. But you see what this will allow you to do is you could run this program multiple times, and you could specify different out files each time you ran it, and you'd put all your programs on your desktop. That could be convenient. Maybe you could use it to, I don't know, generate your homework files or something. So then what we have here is we have files. So this is our file handle right here, that my file tag that we can use to say whenever we're going to work on our file. Right, here's our keyword open, and we're giving the out full path, which is this right here. So this will be a string pointing to the name of the file, and the status is W. So notice that we did not have the correct status. It used to be right, which is incorrect. You need to use W. File.write the message. So what we're going to do is use the file defined above to write the message. Then we have file.close. So we have to use file, not the full name, and also you need the close parentheses. So if we just compare these lines to how they were before, we see this was not right because there's no parentheses here. Okay. Yeah. So there we have it. A few corrections were necessary to in order to use that. Okay, yeah, and also this line right here had a difference as well. So it's file.write message, and it used to be out full. Yeah, see how this is using the name of the file itself. So you might be tempted to do this to try to give the name of the file, but that's the wrong thing, right? Because you have to use whatever you call that file. It's this file right here, which is the file handle, not specifically the text name of the file. That's not what goes there. You have to use that file handle whenever you're going to open, close, or write to it. Okay, and then it takes a note, and so this is back out in main. So this will take a note to put in there, and then we're going to run reminder, which will have the note and the txt. And so the message is what gets whatever you type here, right? So how did that work? So you see here, we're doing the function call with reminder. Note is what's being sent up, which is whatever you typed is the message. And then note.txt is the name of the file. So when this function starts, remember there's an implicit variable assignment happening here. So message will be assigned to whatever note says, and note.txt will be assigned to the out file variable. So definitely feel free to type this in yourself and try that out just to see how it's working. If you have any questions on how it's running, or just, to try it out. So suppose we want to open a file for reading. So now we wrote to a file, and maybe we want to read it. So an existing file is opened using the open command. So the status of the file determines how the program can interact with it. So R is for read. So this is our syntax. The file variable, that file variable again, the equals open the myfile.txt, and then we're going to put a status here. So notice this is really similar to the way that we had set this up before, but notice that there is an important difference. Then instead of the W for write, we have now selected R for read. And that's the major difference between the two statements. So if you want to read in the file as a single entity, that's probably the simplest thing you can do in order to just read the whole thing. So read allows you to read in the entire file. It's not broken into any lines. It's useful when you want to analyze the contents as a single entity. So it means you don't need to see it line by line. So if you wanted to, say, for example, read in the file and sum up all the numbers that were the contributions to our tax amount, right? Maybe you wanted to read it in one line at a time, but this will not do that. This will read it in just as one text. That's it. The file must already be open in the read status in order to do this. Kind of makes sense. So you have to make the status match what it is you want to do, and if they don't match, then you're going to have some problems. So here we have a file variable .read, and that's basically how it works. Again, notice that the file variable is that file variable that you use to open it, not the file name itself. read is a function, and it has these parentheses. No parameter is required. So my file.read is how you would do it. So let's view the file contents as an example. So reading and viewing a file. File equals open. So we're going to open that airplanes.txt document that we made earlier on my desktop. And now notice that it's in the read mode. Notice also you can use either the single or double quotes, doesn't matter. So here we have content equals file.read. So notice what we're doing is we're reading the file in, and all the contents that are in the file are getting sent out, right? Just like any function, getting returned to the variable called content. And then we can print the content, and we should be able to see what was in the file. And here we have file.close to close the file. So when we execute this, this is what we get. Okay, so here's we're restarting this up, right? And here we see that all of the content of that file that we created earlier. Looks like I added a few more things since the last time we saw it. But anyways, this is what it looks like. And just to keep myself honest, I have also opened this in Notepad on my desktop to show you what the content of that is, and you'll see that it's the same thing. So basically, you've been able to read in the content and print that to the screen. Suppose you wanted to read a file line by line. So the read line allows you to read in a file a line at a time. The file must already be open in the read status, and the file advances by one line each time read line is used. So what we could do is file variable dot read line, just like this. So my file dot read line is what it would look like. So let's read and view the contents one line at a time using a read line. So file equals open. So here we've opened the file again, and here we have that in the read status. Line 1 equals, so here's a variable, equals the result of file.readLine. So it will read one line, and then it's going to print it. Read another line, print, read, print, read, print. And look, I've done a curious thing here. What I've done is, just for illustration, I've put in file.readLine beyond the number of lines that are actually in the file. So I wonder what will happen. And just so it will be able to see what happens, I've added to this print statement this line 7 and line 8 inside the print statement, so we'll be able to see what where those lines actually are. So when we come over here and look at the restart, we see that it's read each one in. Notice that it does in fact actually add an extra line between each of the lines that it reads. So that's just part of how readLine prints it to the screen. It's for some reason puts an extra blank line in here, which is a little bit annoying, but anyways, that's how it works. And so we see that it reads in each of those. So essentially the contents are the same, aside from the extra spaces. And then the other thing we have here is what will happen if you read beyond that. And so we see that no error occurred, but it did print line 7 and line 8 and left them as blank, even though line 7 and line 8 did not actually exist in the input file. So suppose you wanted to read in the contents as lists. So read lines with an S on it allows you to read in the entire file, just like read. So that's similar to read, right? So read also allowed you to read in the entire file all in one go. But each line becomes the element of a list. So that might be useful if you want to do some sort of list-wise elements. The first file must be open in read status in order to read. Makes sense. So here we have the file variable again, dot read lines, and so it would be my file dot read lines. So let's go ahead and try reading a file like that. So here we go. F, so this is our file handle equals open, so we're going to open that same text file that we've been looking at in the read status. Lines, S equals F dot read lines. Okay, so that now it's supposed to read it in as a list. Then we're going to print it and do F dot close. So let's see what happens. Oh, look at this. We have the square brackets. Oh, it became a list. So what we got here is we have that there are each line becoming an element in the list, which is a string. And so that's why it looks the way that it does. And the line breaks, you see that are down here, create a new line in the list. And there's our list. So this might also prompt you with the idea of, well, is there a way to cycle over the contents of the file? So we've had looping over strings, we've had looping over lists, and we've had looping over dictionaries. So it kind of makes sense to say, I wonder if we could loop over a file. Is there overloading for doing that? And the answer is yes, there is. And this is how it's done. So this is a method that's available for working with files. So we do file variable equals open my file. Again, it needs to be in the read status. So we're going to do for line in the file variable. Then whatever you want to do with each line, and then we do the file variable dot close. Okay, so again, this is the handle for your file. Here we're opening a specific file in the read status. This is our loop structure. This will be a variable, the line, and then in file variable, which needs to match what you just defined up here. The loop body will be whatever you're doing in that, and then we're going to close, because whatever you open, you also need to close. Thumbs up must come down. What's open must be closed. So let's take a look at an example of reading a file with a for loop. So here we have opening a file. So we're going to do for line. So this is the name of the variable, the index that's going to be used over each of the lines in the file. For line in F, notice that this F matches to this file handle right here, and that it's not matching to the name of the file itself. Print the line and then close. So pretty simple script. It's going to read it in, print out each line, and then close. So here we go. Here's the result of that. And again, we see our exact same file being printed out to the screen. So that brings us to the idea of idiom. We've kind of talked about this before in a more general sense, in a maybe not a very focused sort of a way, but we talked about how when you have a process that you want to do, there's a kind of like a set formula that you would use in order to do that process. That's what an idiom is. We talked about this when we were talking about the while loops. So we said, hey, when you're going to have a while loop, you probably want to have some sort of an index to go over the loop, and you probably want to initialize it at 0. Then you have while and the guard, and then you need to increment that index, so I equals I plus 1. Now, are there ever instances when you would deviate from that formula? Absolutely. For example, maybe you want to start your counter at another number, or maybe you need to count by 2, so it would be I plus equals 2. Or maybe you want to do the while true version, right? So there are other ways that it could be done, but an idiom is like the common way that you would most likely want to do it. It's sort of like a rule of thumb, not necessarily like a syntax, right? A syntax you really can't break, but an idiom is more flexible than a syntax, but it's like, this is how you should approach the problem and modify it when and if it's needed. So here we have idiom defined as a sequence of tasks commonly done by users in a pattern. So an idiom is involving file input and output is read some input from a file, modify the input, write a new output file, right? The typical thing you probably want to do. So here's a brief little code reading exercise for you to have a look at. Why don't you just take a moment to pause this video and have a look at the code that I'm showing to you up here that has code reading and writing. So try to understand for yourself what the code does, identify the parts associated with the input, modify output idiom. So go ahead and pause that for a moment and we'll come back and talk about that when you're done. All right, so welcome back. So let's take a look. Have you been able to understand what the code is doing? Let's take a look. So I see that it is going to open a file called numbers, and it's going to print open file. It's a little message to us to know that it got past this. Numbers equals this empty parentheses. So here we have our list that's being initialized as empty. So now what we're going to do is for line in read file. So you notice that this is the code that we previewed at the beginning of the lecture. And so now that we've talked about how to read files, hopefully you understand a little bit better of what's going on here, right? So this is a for loop. This is the for loop variable line in the name of the file. This is our file handle right here. and it's going to convert the line into an integer because we have this int coercion in the body of the loop. Then it's going to do numbers.append line. Oh, right, here's our numbers up here, so it's going to append some numeric data into a number and add it to numbers, and then it's gonna close. Now numbers.sort we haven't seen before. What this is going to do is this is a method that will actually sort things. So you can put things in order. So for example, if you get a series of numbers, it will actually sort the numbers for you. How convenient. So then what we can do is we can then open a file for writing. So here we're opening the file for writing. Notice that here's the W for write, whereas before we had R for read. And now what we have is for a number and numbers. So we're cycling over our this here, the list that has the numbers in it. It's going to write the numbers, and you see that it's converting them back to a string, because when you're going to write it out, what's the type that you need? You need a string, and the type is not string because it's in numbers in order for numbers.sort to work. So we have to convert it back. And then we close the file. So we see that the idiom is read, modify, output. So here's the reading part where we open for reading, and this is where we did the actual reading in. The writing part is, the modify part is right here, sorting the numbers, and then the write part is right down here. We open the file for writing, and here's our for loop that's doing the writing. So this nicely illustrates the read, modify, write idiom. Okay, so here I put another little practice exercise for you. So starting with the remainder program, which we have seen over on the right, add another function, read remainder, to allow it to read the note that was written and print the contents to the screen. You may assume that the file is on the desktop. Don't worry about the paths yet. Yeah, we'll talk about that momentarily. How many different ways could the contents be read in? We talked about several. 4 as a matter of fact. How can you do it? And which would be the most convenient? So why don't you go ahead and just pause this video and think about those questions, try it out and see if you can answer them. And when you are ready to resume, join back here with me. All right, so welcome back. We're going to now step through this remainder function, and also you are working on building the read remainder function yourself. So let's take a look at what's happening here. So in the reminder function has a message and an out file, and so what's happening here is we are going to create a reminder, right? So we actually saw this a little bit earlier as well. So here's the out full path. So this is going to write to my desktop. Now, if you're trying this out for yourself and you're using a Mac, then this path isn't going to work. So we'll show you how to get the correct path, and actually our lab is going to explore that in quite a lot of detail, and actually that will be one of the major focuses of the lab, is discovering the path on your computer, which could be unique to all other computers. Okay, so here is the path, and here is the out file, so it's going to join those things together. So file equals open, and this will give the path, and that will be for the writing status. So we need to make sure that is correct. Then we're going to do file.write message. So what we're going to do is that message that you've set up is the input, right? So here's note equals the input of the message, and then when we call the reminder function, we send up the value of note, which is whatever you typed, and the file name is going to be note.txt. So when this function gets called, there is an implicit variable assignment. So the value that was sent up for note, that is the message, and this note.txt string are implicitly assigned to message and out file respectively. So what we're going to do is now open that file using the information provided by the user when they had the function call, and then it's going to write the message. So what's going to happen is that message is going to be written to the file, and then we're going to close the file. So that's how you can write your reminder. Like, don't forget, I have a dentist appointment today. Okay, now we want to read the reminder. This is what we're going to do. So here's def read reminder and the file name. So it looks like we're going to need an input parameter. So this is going to have the assumption that the file exists on the desktop and is going to read the file called file name. So here's the path to the file. Again, there could be a concern with this actually working on your computer with this path right here, so that may need to be adjusted for your respective computer, plus the file name. So file equals open the path for reading status. So now we're going to be able to read it. So in the function above, we wrote it. Here we're going to read it. So print file.read. Read the file as a single entry. And then we're going to return. Here is out in main where we have those function calls. So we've already looked at this. And also here is where we are reading the note. And that is how we can illustrate using the read modify output idiom one more time. So why stop at reading and writing? There's one more thing you might want to do, and that's called appending. So why do we need to have appending? Suppose you want to add something to a file that you have. Suppose you started your homework and you're like, oh, I forgot to answer the last question. Oh no. And so what do you want to do? Do you want to start from the beginning all over again? Of course not. You want to be able to open the file and put on the new answer at the bottom of the file. That's what appending is about. You want to write to a file which already exists using the W. And so if you use the W, what's going to happen is it's going to overwrite the existing file contents. This is equivalent to doing a variable assignment. So if you have x equals 5 and then you say x equals 6, what will happen? Well, the 5 will get overwritten and it will become 6. So if you use W, what's going to happen is you're going to overwrite the file with whatever you tell it in the new time. So maybe you do want to do that, but oftentimes you may want to append to the file. That is, add new content onto the file, just like we've talked about appending to lists and appending to dictionaries. So to append new content to the end of an existing file, you need to open the file with the status A for append. So this is what the syntax looks like. You have, again, that file variable that we've now seen several times. Here's the open, and here is A for append. That's the name of the file you want to open. If you're going to append to a file, presumably the file already exists, right? So then you're going to write to the file, and this is what stops it from clobbering because it's an append. Whatever else you need to do, maybe you're writing some more lines, blah, 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 whatever. And then we're going to close. So we have our file variable dot close right here. So here's an example of how to append to a file. So what we're going to do is we have our file handle and we're going to open the file. Here's our open command. So we're back to our airplanes.txt file. It's on my desktop in the append mode. And so maybe I wanted to put in some more aircraft in my airplanes.txt file. I forgot. Okay, so here we go. We're going to do file.write. And so here's some additional text about other aircrafts and listing out some specific examples. So we have a couple more lines of text here. And then what we're going to do is file.close to close that file. And so here what we're doing is opening the file in the read mode. And now we have for line in file, print the line and close the file. So what we're expecting is going to happen is it should now include these new lines. And ta-da, yes it did. So the new lines that we just added are about the other types of aircraft, these, 6 to 7 lines over here. So we see that that has happened in the output. And just to keep me honest, I've also opened the same document using Notepad, and you can see that it's the same. So here we go. All right, so that concludes our discussion about reading, writing, and appending to files. The next thing we need to talk about is navigating the directory tree. So what do you mean about this tree? You mean I have a tree in my computer? What? What is this about? There is, in fact, a tree in your computer. It's called the directory hierarchy. And this starts at a place called root. So it's kind of like an upside down tree. The reason why it's called a tree is because similar to a tree, something is inside something else and it branches out. Okay, so we want to get this idea of you start somewhere and then you can go from that place, that common place, and then you can go to all the different places. So just like so ignore the root system in the tree, just think about the part of the tree above the ground, but imagine that we're upside down. Does that make sense? So what we want to do is we want to say, where did the tree start? So directory trees start at root, and the root is given by this /. Why did they fit that? I have no idea. But this is the /, that's where everything starts. What is root? Root means this idea that on your computer, all the files and directories have to be inside something. They all have to be on your disk, right? So how do we call that original point, that point of origin? That's what root is. So the root is usually your hard disk. If you have a partition drive, it's a little more complicated, but let's imagine you only just have a plain ordinary single disk. But if you have multiple disks in your computer, yeah, you could have multiple disks. One will be the primary disk. But let's not complicate things too much. Let's imagine you have one disk on your computer. That is, you have one hard drive, which is the situation for probably just about everybody. So here's your root. Okay, so in root, then all the stuff that's on your computer has to be in it because it's somewhere on your computer, right? So it all must be on your hard disk. Okay, so let's think about what are some of the things. So this is highly schematic, and there's definitely a lot more other things that could be on your computer and probably are. So anyways, we could imagine that we had some directories. So what's a directory? That's a folder. Usually think of these as those little, those folder icons. You could have a folder icon for applications, library systems, and users. So users is probably where you spend most of your time. That's where your home directory is, where your desktop is, and all these other things. How do you suppose your desktop decides how to show some things? Well, it in fact is actually just a folder in your directory, and it's showing the contents of the folder on your desktop. That's where it came from. Okay, so these are just some other folders you could have, other directories that could be on your computer. These are highly schematic and probably do not represent the actual directories that are on your computer. You will be discovering those in the lab. So what we're saying is, in this computer, there are two different users. So you have Bob and Carol. And Carol has been an industrious person and apparently is taking a physics and English class and decided to make a directory for each of those classes. Bob, on the other hand, doesn't seem to be particularly industrious, and it looks like he just has an empty folder and he didn't do any work. And so Carol has done something. So in her physics, she has another directory called foobar, which I guess is maybe some physics project. And she also has something called project.txt. So I guess she's working hard. And in her English class, it looks like she's written a mypoem.doc poem, maybe for her homework or something. So suppose we wanted to say, what is the path to mypoem.doc? So this can be traced out by saying which folder it's in. So you'll see that mypoem.doc is in the English folder, which is in the Carol folder, which is in the users folder, which is in root. So do you see that all things that exist on this tree could be traced back to the root, and they'd all have a unique path. So project.txt is in physics, and Carol and users in root. The library is in root, Bob is in users is in root. So that's how you would trace back the way to root. But when we give the path name that is showing how to go from root to the file, which is the other direction, we start at root and we move through. So this first slash right here indicates we're starting at root and tells us how we step through the files. So in order to get to mypoem.doc, we went from the root, which is the slash. Now notice that these slashes don't really have the same kind of meaning as the slash does, right? Because there's not a separate slash folder. So root is unique in that. So our path to mypoem.doc is slash for root, users, Carol, English, mypoem.doc. And that's how you would get there. So OS and the directory tree. OS is a Python built-in library that's going to help you work with the directory tree in order to do things like move between those folders. So what you need to do is you need to import OS in order to use it, just like we've done import math or import random. So import OS for operating system to access the methods to help with the file manipulation and directory structures, like the math module, OS contains a number of useful methods for working with the directory tree access using the dot notation, which we have seen before. So one important thing you want to be able to do is locate the current working directory in your directory tree. That directory may in fact be different for each person, which makes things even more confusing. The current working directory is a location in which Python is currently working. That means if it were going to read or write something, that's where it's going to put it, unless you tell it a complete path that is starting with root. But if you're just looking for, if you just say like, write a file, right, it's going to look in the current working directory. It's like the folder that you're standing in. In Windows world, what it means is whichever folder you have open, that's the current working directory. Imagine that there's a pointer selecting a directory in the directory tree. So what would that look like? So here is an example of somebody in Windows, and they're going through and they're pointing to. So this person is in Lori Documents HTG Images. And here this person is going to change the default picture location, right? They're about to click on this folder. So that's going to change where the pointer is at. It will change the working directory to be inside that folder. This may or may not be the same directory in which Python was installed. So Python has installed itself somewhere in your directory tree, probably not in your user account, probably in some of the system files. And you may have a pointer to something in there as your current working directory, which I would not recommend using because you probably are not used to going there. Or it may not have a pointer to there. It's different between different computers. I've looked at this in different machines, and it seems that the Mac and PCs do have different versions of what they do, but it also depends on the version of Python that you have. So really the best thing to do is to just find out where Python is working on your particular computer. And one of the things we'll be talking about when we get to the lab is just change your working directory to some place you want to be. Don't worry about where it starts, just tell it where you want it to go, and that's probably the safest thing to do. So to locate your current working directory, this is what you can do. You will most likely be doing this from the interactive Python shell until you are familiar with your computer, and then once you work out what your paths are, then you'll kind of know this already. Don't forget to import OS first, so I recommend doing all your imports at the top of your scripts, or if you're running your Python session interactively, as we're recommending for you to test this out and get started, make sure you import OS first. You can consider the double slashes reported by Python as a single slash. So notice that there's a bit of confusion here because the paths that I've shown you so far have single slashes and they went in the other direction. But when Python is reporting them back to you, it reports them back differently, and that's very confusing. So you just have to be aware of it, and this is kind of just how it is. I have a compilation of tips and tricks that will help you sort all of this out. So here we import OS, and now I'm going to do os.getCurrentWorkingDirectory. So my Python is saying that its current working directory is in my Dropbox in a Python directory called Lecture 1. And here I'm showing you what that looks like on my Windows system, and this bar up here is showing you the path to the same place. So suppose you want to see what's in the directory. Might be a useful thing. You want to do list dir, which is going to return a list with the elements being the names of the files and or directories. So recall that dir just stands for directory, which is really a folder. So list dir really just means list what's in my folder. Yes, we also have the dot. This is the dot for the current working directory. So if we do os.listdir and then you give a path to a directory, it will list the contents. You can also do os.listdir and you can give it the dot. That means list the contents of wherever I am right now, sort of like the default behavior you would expect it to have. So here's an example listing the contents of the current working directory. So here I've imported OS and I did os.getCurrentWorkingDirectory, and it tells me that I am in users Kelly Dropbox, and this is my Python folder, and I'm in the folder called Lecture 1. And now if I do os.listdir, look at what it gives me back. Oh, we got this huge list. Okay, and notice what the list is composed of is strings telling all the different things that are in this directory. Okay, so you might recognize some things that we have visited before, some file names. And so what you can do then is you can go to one on your own computer and you can try to list the contents. So suppose you want to list the contents of another directory, not one that you're in right now. So you can do lister, which will return a list with the elements being the names of file and or directory specified by the path. And what you do is you just specify a directory within the current working directory, and that will cause that one to be listed. So that might be one example of another directory that you want to see. So it will assume the current working directory / and the directory that's in it. So if you're standing in a directory that contains directories, you can do that. If there are no directories where you're at, then that's not going to work. So any directory can be listed by specifying the complete path to the directory of interest. So that means you would have to give it the complete path starting at the root if you want to list something else that's not in the directory that you're in. So that would be os.lister, and then you would give a path to it. So let's list contents of another directory. So here we are importing OS, getting the current working directory, and now we're on the desktop. Okay, so now I'm going to do os.lister and get the current working directory. So this shows a list of all the files and directories that are on my desktop. Okay, so now what I'm going to do is I'm going to do os.lister Python, which is a directory that is in the current working directory. That is, there's a folder called Python sitting on my desktop, and since I'm on the desktop, I can just do lister of Python, and it will tell me that I have some homework files in here. Suppose I want to list contents that's not in the current working directory. So notice that this path is not on my current working directory. Users Kelly pictures, okay? Not on the desktop. It's parallel to the desktop because it branches after Kelly. So Kelly must contain both desktop and pictures, which it does. So that's not where I am though. I'm on the desktop, and so the tree branch would go up and around. And so what we're going to do then is specify the path to it, and now it will do that. So here's some stuff that's in my pictures. Suppose you want to change directories. Maybe you don't want to be where you're at. You notice that when I got my current working directory that I had somehow magically gotten myself into another directory. Well, how did it happen? So that's because I changed the directory. So changing directories means changing the current working directory. That is, that little pointer gets moved to someplace else. It's convenient to move the directory to where you are working. Like if you want to save your homework there, don't have to keep typing the full path. Just go to the directory. The name of the directory is represented as a string. So some popular current working directory choices could be desktop, my documents, Dropbox, cloud storage, and so forth. Here's some example of syntax. os.change directory, and then you give the name to your directory. So os.chdir, and here this is how I could get to my Dropbox. Now, if you don't have Dropbox, this of course isn't going to work. And also you may or may not have the same style of path, and if you're on a Mac, it's going to be different. I'll show you what to do in a moment. Okay, so you can use os.getCurrentWorkingDirectory and os.ChangeDirectory together in order to navigate through your system. So Python will begin in a default current working directory. As we said, we can't really predict where that's going to be. It will be one of several choices, but highly dependent. Don't count on being a convenient place. So then what you want to do is you want to check where your current working directory is located using os.getCurrentWorkingDirectory. And then you can move to a new directory if desired using the os.ChangeDirectory. Verify you've moved to the desired directory then by giving the os.getCurrentWorkingDirectory again. So it should tell you back, yes, I'm in the directory that you told me to go to. So here's an example. Here we import the operating system package. Then we do os.getCurrentWorkingDirectory, and I see that I am in users Kelly app data local programs Python. Good grief, not convenient. How am I ever going to remember this? If I'm looking for my homework, I'll never find it. So what I want to do is I want to change to my Dropbox, which is where I keep my files. So I'm going to do os.change directories and go to my Dropbox. Now I'm going to verify that I got there. So I'm going to do operating system.get current working directory. Oh, there I am. Now I'm in my Dropbox. So much better. Now I'll be able to find my files. Okay, the next thing we can look at is we can look at os.path.join, which is a really useful thing to use in order to be able to manipulate your file paths. So when in a particular directory, do you agree that the path up to that point would be common for all files that are in the same directory? That would have to be true, because if they're in the same folder, that same folder must be in the same other folder and other folder, so forth, because they're in the same folder, right? So what that means is the path up to that point is exactly the same. And so this could be really useful if we wanted to generate the complete path for everything that is in that directory. So a new path can be created by joining the beginning and end parts of the path using path.join. This can be useful for generating the complete path for a file or a group of files in the same directory. So here's how we would do it. os.path.join, here's the start path, that common part, and that's the rest of the path over here. So here we're going to combine C user Bob desktop with airplanes.txt. Let's take a moment to review a few notes on paths. You must use quotes, so the directory name has to be in quotes because it's a string. Direction of slashes. Now, the slashes typed in the commands may not match the direction of the slashes reported by Python. So notice when I type my slashes, so here's an example down here. When I type my slashes, so I do os.change directory, I'm using the /, but when I ask Python to tell me about what the path is, it's using the slashes in the other direction, and it's also displaying them as a double slash. Yours may or may not do this. So make sure you just keep straight how you're supposed to type it, because it's important, and it's not necessarily the way Python shows it to you. If you type the wrong slash, Python will interpret it as the escape command, such as we use for the new line command. So that's why you can't use it. Single slashes, note that you must type a single slash between directories, but Python may report them back as double slashes. That's what I just showed you right down here. So just be aware that this is how things behave. I know that it's a little bit confusing, but unfortunately we can't change that. So we just have to learn how to work with it. I also just want to share a few tips and tricks with you. So this is some similarities and differences and things you should be aware of depending on whether you're using a PC or a Mac, or so Windows users, PCs, to use the / to separate the directories, even if your system uses the \. If your system reports double slashes, only use a single slash. So I showed you that my system does this, and also it does this. It shows the slash in the wrong way. And here is an example of how my slashes should look and what the syntax should look like. Notice that mine also starts with this C right here. And so the name of the hard disk on Windows machines almost always is called C, unless you went in and changed it and called it something else. And so that's basically how that should look like. Mac users, do not use the drive letter in your path. So your drive may have a letter, but see how this has C? Mac users don't use that, so don't do that. Instead, begin your path just with the root, and it looks more like what our actual directory tree looked like. So be just aware of that. Even if it says like /Mac HD, or it might say /Mac or something like that, don't type the whole thing, even if it tells you that. You just type root to get started with your path. If you're a Windows user, you start with the C, well, it actually usually shows that, that's the name of it. But those are some differences between the two operating systems. To get the path info, you want to use the right click and get info in your file browser windows, and that will help you to see it. So that's going to work a lot better. This also is reiterated in your lab, and when you're actually trying this out, I'll be reminding you to do this so that you can see your paths. Windows users, it should be displayed automatically. Mac users, it's probably not unless you already turned it on for some reason. Do not include the Mac HD in your path, even if it shows up in your system that way. That's the name of your hard disk, which in Windows is C, and in yours is called Mac HD for hard disk or hard drive. So hopefully that will help to alleviate some problems that you may encounter as you try to work through actually trying this out on your own computer. All right, this brings us to our final topic today, and that is handling exceptions, that is errors. What is an exception? Exception is an error of some kind. So to handle an exception or to handle an error means to provide an alternate code to execute if a particular kind of an error is encountered. Do something else if this doesn't work instead of crashing your program. I mean, ultimately, what we'd like to do is we'd like to write code that will be fail-safe against crashing. We've already talked about some ways of trying to fail-safe what happens using if blocks and flow control and these other kinds of things. But we want to make it so that there's never an opportunity for your program to crash. That's bad, and you don't ever want that to happen. So what if you don't know what will happen next? So if you realize that there could be some possibility of your program crashing, what we want to do is put in that fail-safe and say, okay, if this happens, then there's something else that we could do to take care of that. My dog is barking. Max! 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 Say hi! Oh, can you see him? There he is. That's my dog. He wants to learn how to program in Python. All right, so back to Python. So what we're going to learn how to do is do try and except blocks. These can be used to handle exceptions. So what we'll do is we'll say, for example, try to open this file. And if we had an exception, that is an error, like the file doesn't exist, what should we do? How about we would create the file? Sounds like a great idea. You wouldn't just want to create it though, because if you created the file, it'll overwrite one if it already exists. And that's why using a try except block is a much better way to handle that. So the file not found error occurs when a file doesn't exist. So if you try to open some file that doesn't exist, this is what you'll get. I'm sure you're familiar with getting errors by this point in the class. I'm sure you have had a few, and you know, it happens. I even still get errors. So that's a particular kind of error, and that error pertains to opening files that don't exist. So then we could bring in a try except block. Could be used to handle a situation where a file does not exist. So maybe we don't know if the file will exist or not, or maybe we're writing some code to run on somebody else's computer and we don't know if they made it, or all kinds of situations could come up where a try except block could be a really useful thing to use. So Python is going to begin by attempting to run the try branch. That will go first. That's like the default. If the error is named an except occurs, so when you have an except part, you'll have like a branch, and that is going to contain an error name that that could happen. So if the situation shows up that there is the file doesn't exist, file exception error happens, then you want to do that branch instead, like create that file. So it would look like this. So you'll see that you have try and except, and they're both indented at the same level, just like we have if and elif, right? They're indented at the same level. And here there's the body, which could contain whatever you want to be in here. It could be while loops, some whatever it is. And then we have except, and then we have a body for the except down here, whatever you need to put in. So here's an example of the try except block with the file not found error. So here we're going to try to open a file. So we're going to try to open some file.txt with the status R for read. And then it's going to print, I can read some file.txt, and then it's going to read it. And here's the except block. So if the file not found error is raised when it tries to open this, or in fact, it would be if it were raised anywhere here, but this is the line in this particular code where you could get a file not found error, because that's where we're trying to open it. I would print, I can't find some file.txt. But because we have this except block, try except block, it won't crash the program. So if we didn't have this in here and we tried to open some file.txt and it didn't exist, then the program would crash with an error. But because we have this try except block, if it doesn't find the file, it's still going to continue and it's not going to crash. That's the advantage of using try except blocks. So you should think about, if you're using file IO in your projects, whether or not you need to include a try except block. Okay, so there's also value error. You may have encountered this before. That's when you have the wrong type. So if we do int of something that's not an integer, like this string, not an int, you cannot convert this string into an integer, and so then we would get the error value error. Notice that when we're getting errors, the name of the error generally is given. So we haven't really been paying too close of attention to what all is in the error message that comes out. Now it's useful to watch and pay attention, because usually when you're using the try except block, you look to see which error happened, and then you want to do except, and you want to put the error that shows up here as the thing that the except block is checking for. So let's try to use a try except block with a value error to test the input. So here we have a while true loop. We're going to try to do int of input please type a number, and here's number. And so we have except value error, sorry, that is not a number, and continue. And then it's going to keep going. And when it's true, right, when they do finally figure out to type a number, not everybody's as smart as you, then what's going to happen is this will not cause the value error, and it will continue on to here, and it will hit the break, and it will exit out. But if they do type something that's not an error, the value error will be raised, and it will print, sorry, that's not a number, and it's going to go right back up and continue in the try except block. Notice we also have this continue here to facilitate that. And finally, when they get it right and this breaks, then we'll see you entered a number and it is blah, blah, blah. All right, so I have a little exercise for you to look at with this multi-branch try except. So what we're going to do here is we're going to import the operating system, and then we're going to change directory to the desktop. Here what's happening is there is a file containing some numbers, numbers.txt, open for writing for I in range. Now remember how range works. Start, stop, and delta. So this is going to count backwards by 1 from 5 down to 0. And then it's going to print it. So here's file.write, and notice that we've converted it into a string because write only works with strings. What's this do? This /n, that is going to be for creating a new line. So what do you think is going to happen? What do you expect the output will be? What kind of errors could the grade code produce? All right, so down here we have a few more things happening. All right, so this file, this part up at the top, is creating a file. So what I want you to do is to write a try except block with multiple except branches that's going to catch all the possible errors that could come up when this is happening. So when we think about that, we want to think about, well, what could happen? Is it opening a file? What error could happen with that? Now also we're reading in some numbers. Is there any possibility of an error that we know about that could happen when we're trying to deal with numbers? So take a moment, pause the video, and try that out at home. All right, welcome back. So here's a solution to this multi-branch try except problem. So what I've done here is I've written a for loop, and I have some try excepts down here, okay? So we're going to handle two types of the exception. So what we're going to do is we're going to open a file for reading. Here's the numbers for line and file. We're going to write that, sort the numbers, and now we're going to do file W for writing, open sorted text in the writing format. So here we are doing a loop for numbers and for number in numbers. This is looping over our list up here. We're going to do file W.write. This is the file version that we open for writing, string of the number, and close. All right, now I can see that there could be a couple things that could go wrong here. So the first thing we could have is we could have a value error. That's when you have the wrong type, okay? So print the file contained a bad number. All right, so that will stop the program from ending when the person enters something that's not a number. The other error we could get is the file not found error, and that could happen when we try to open a file that's supposed to already exist. And so then we could get file not found, so this will say a message couldn't access the file. So this is a really nice little blog that exemplifies picking up those two different errors. What this doesn't do is this doesn't cycle around and give them another chance, which is a feature you might want to add. But anyways, this gets you the idea on how to have multiple accepts. So you can have as many accept branches for as many different errors as possible. Obviously, you can't have different accept branches for the same ones. You can't have accept value error twice, but you can have different possible things that could happen that may have arisen from different points up here in the body of the try branch. So try accept blocks then are going to be affecting the flow of the program, as you might have imagined. So for example, we could have this divide 5 by divisor. So here we have return 5 divided by the divisor. So try to print divide 5 by 3, but of course division by 0 is not going to be okay. And notice that this code is dead code here, right? I saw a lot of this on your first exam. Notice that what happens is either it's going to be fine or not, and then what's going to happen is we're going to have the zero division error. So that's when you divide by 0. So when this happens, so this will be fine, right? So it does that, and then it gets here, and the accept 0 division error will get raised because it can't divide by 0. So it's going to go down to the accept branch because, oh, no problem, but I'm in a try accept block. Let me see if I have some information about what I should do when this bad thing happens. So 0 division error, yes, exactly my problem. Yes, this is what happened. And so it will print something went wrong. So because the flow is diverted here at this point, it will never in fact actually get to this print statement right here. All right, so that concludes our discussion on file input and output. Let's just review what we've talked about today. We talked about an introduction to files. We talked about programs and files and how to write output files, some of the features of them. We talked about reading and writing files. We talked about how to open them, how to open them for reading, how to open them for writing, and closing them. And we talked about 4 distinct ways to read a file and how to append to file and what an idiom is, particularly in the read, modify, write way of dealing with files. We also brought up directory trees because that's very useful. We talked about what they are and how to step through them. We talked about the current working directory, how to list directory contents, and how to change between directories, and the path syntax tips because paths can be a little bit confusing on the different computers. Finally, we have talked about handling exceptions. That is, when you get errors using different things that could come up. So to do that, we could use try accept blocks. So we talked about a couple of common exceptions to handle. So we talked about it in the context of file not found error, division by 0 error. And so basically you can use the handling exceptions with the try accept blocks with just about any problem that you've encountered in the class. All right, so thank you so much for being with us. Looking ahead, just to have these things in mind, we have the file IO homework due, so again, you should be doing that to turn in a week from now. You have your lab this week on file IO, which I definitely encourage you to attempt before trying to do the homework because the lab will really help you to work out the file paths on your particular computer, which will be necessary in order to complete the homework. I also mentioned for the homework, this one is a little bit distinct from the others because you need to download a file and a sample of directories so that we can ask you some questions about how the directory tree works. So you need to download that and put it on your computer. I'd recommend just doing it right on the desktop and just change your working directory to your desktop. Also, your final project preliminary results are due, actually, I'm not sure that it is in 1 week. They are due in lab where you've attempted any 2 or 3 of your goals. So let's just quickly flip back to the calendar to remind ourselves when they are due this semester. I may have neglected setting that up. Okay, yeah, so file IO this semester is preliminary results are due this week. So please try to get those in as soon as possible. All right, thank you so much for being with me today. I hope that this has helped you to understand how file input and output works, and certainly I will look forward to seeing you while you're working on your labs and during any of our other sessions online. All right, till next time, bye-bye.